Hi, this is SUI 778 coming at you, and today we have episode number 3 of the super tight budget multimeter series, and today's edition is going to be the BTMETER 770G. So let's go ahead and get right to the unboxing. As you can see, it comes in a plain Jane box, 770G. Not much to it really. There are some specs back here saying, you know, the variations on the different models. Again, this one's a 770G. This is definitely one of the cheaper models. Anyway, let's go ahead and get this unboxed. See what we get. And it comes in a case. All right. Well, means we can get this out of the way. So inside the case we get a thank you with an offer to extend the warranty for 180 days. All right. The user manual, and this is just like a single fold-up sheet. So, got some specs on this page right here. Hopefully you can see that. And then some more down here. Quite a bit. Okay. Anyway, so we get that. You get a set of leads, a pair of AA batteries, Thermoprobe, and last but not least, we get the multimeter, which has a screen protector on it that we're going to have to take off immediately, just simply because these numbers are going to get in the way of what we're doing. So here we go with the de-virginization. Enjoy. Voila. Okay, let's get over to the overview. Okay, and before we get into the overview, I just want to show a couple of features here on the back. As you'll notice, this stand is a little bit at an oddball angle. It kind of makes it face more upwards than most multimeters, and also this thing right here is a magnet. Now I'm guessing the reason for that is to have the ability to like stick it on a metal surface to where it will just stay there while you're taking readings. Well, it's not strong enough. It is strong enough to, as you can see, suck my screwdriver into place. Anyway, it's not strong enough to stay on a fridge or a metal surface because I tried it, so I'm not really sure why that's doing there. But anyway, just be advised that there is a magnet back there. I don't know that I would want to keep this on there because this is not really very well shielded either. So I'm kind of like, I don't know that I would want to have that on there. But anyway, let's go ahead and go to the overview. Going from top to bottom, as we can see, we do have a backlit LCD display. This is actually controlled by an auto dimmer. There is no on-off switch, but if it gets dark enough, it'll come on, and we'll show that here in just a second once I turn it on. You've got a hold, which is basically just a freeze frame, select button for your functions for selections that have more than one function. That's basically just going to be this one here with the diodes, continuity, and resistance. You got the manual range button. We do get a rel button on this, hertz and a duty cycle button, and also an NCV button. This non-contact voltage works a little bit differently than most. You actually can run it from any mode. It's just that you have to hold the button in when you're doing it. I'm like, okay, so it kind of works more like one of a more conventional, like the pointer style non-contact voltage finders or whatever. Okay, let's go ahead and turn this on. Going from left to right here, as you will see, we have AC/DC amps, AC/DC milliamps, AC/DC microamps, HFE for transistors and whatnot. Temperature, let's see, I'm not sure if this, it looks like it does it just in centigrade. Yep, that appears to be the case. Yeah, okay. You get your hertz, Not sure where the duty cycle is coming from there because I don't see it. I guess it's just controlled by this button up here. Yeah, all right. Does have a fairly audible beep. Okay, next up is capacitance. Then you get your resistance, diodes, and continuity. AC volts, DC volts, and DC millivolts. As you can see, this has no DC or AC millivolt range apparently. And then of course an off. And down here you'll notice that you have protective covers, and they will switch around as you put them in different modes. Just keep an eye on this right here. For example, if we go over to the amps current, you'll notice that we've got it in microamps, so only the two correct holes are exposed. If we go down to amps, it'll switch over to this one and this one. And of course, we go over to more of the common functions over here. You'll just be using your common jack and your function jack for most everything, you know, continuity, diodes, capacitance, volts, resistance, hertz, etc., etc. They don't have a category rating on this. They just say that it is for 1000 volts DC and 750 volts AC. Okay. The microamp and milliamp jack is fused for 500 amps max, or I'm sorry, 500 milliamps max. And then of course we do have a 20 amp jack here, maximum of 10 seconds. Okay, category 3, 1000 volt. I don't think so. We'll take a look inside. And of course we got the fuse for maximum of 10 seconds, 20 amps maximum. You have your transistor jack up here. That's basically going to do it for the features. Oh yeah, let's show you the auto dimmer. As you can see, it does come on. That's kind of handy, I guess. So anyway, there you go. All right, let's go ahead and go over to the battery compartment. Now this battery compartment's a little bit different. This whole thing is going to come off. It's held on by two screws actually, here and here. So let's get that out. You basically just need to pull the whole thing out. It does come out neatly. The nice thing about this one though is you do have exposures for your slots to basically access to swap out your fuses. Looks like we got a PTC sitting down here. I see a couple resistors and a couple other things, but we'll tear it down further. And of course this is powered by a pair of AA batteries that I had already put in. Okay, so let's get that out and we will continue. In fact, we can probably leave those batteries in there. So let's go ahead and tear this down even further. Okay, we did get it off. This is a very thin condom. Not much to it, kind of flimsy. Oh well. Put that aside here. And then inside, looks like we have two screws down here on the bottom, so let's get those out. It's not going to fit with that. Alright, so let's try it with these. See if this comes out. Okay, yep, the screws came out. Doesn't look like there's anything else. We do have brass inserts for these battery, for the to access the battery. There we go. Okay. Well, hope it didn't break anything there. All right. So let me get this repositioned for the PCB close-up. Okay, so here we go with the PCB close-up. Looks like we've got these actually look like screwed-in jacks. These may not be the split type variety. Let's take a quick look here. Yeah, they look like these are just the non-split type, so that's nice. Okay. I got a pair of what appear to be ceramic fuses. This one is the 500 milliamp. It is rated for 500 volts. Okay. And then we've got the 20, what appears to be the 20 amp over here. It is also rated for 500 volts. Okay, so I would say this is probably category 2 500 volts. So it has that going for it. So you got a pair of resistors here. Looks like a couple of capacitors here and some other really small resistors up here. Big current shunt. It starts here and runs all the way over. So that's not that's pretty decent. Got some more cluster. Can't tell what those are. I'll have to put up on the screen what those are because I can't read those. I'm guessing those are probably resistors. They're either resistors or diodes, I would guess. A couple more resistors here. Up top we have another series of resistors here. This, of course, are the battery leads. This probably is the controls for the, yeah, it looks like for the LCD display. Here is your processor right here. We have what appears to be 2 speakers here and here. That's interesting. And I would guess that this piece of metal right here is probably your NCV antenna. It looks like this controls both the LCD display and the functions. Got a bunch of capacitors and resistors down in here. Not much else to this really. The manufacture date on this is actually quite old. It looks like the 16th week of 2015, and this revision is 770G revision 3.1. April 13th, 2015. So this is a fairly old design. Okay. All right. The only other thing I will say is that there is a lot of places where we have some leftover flux, like right here. And some other places, yeah, there's some more flux left over up here. They did kind of a crappy job on the soldering down here too, and yeah, it's kind of sloppy. Yeah, more sloppiness here. Yeah, that could probably stand to be cleaned up. But anyway, there you have it. There is the PCB close-up. Let's go ahead and put it back together and we'll start doing some tests. Okay, so let's go ahead and start with the test. As you notice, we're going to just run single camera today, just simply because this meter has a really oddball angle. So we're going to start off with DC voltage as always. Let me get this into the right mode here. And as you can see, the switch around. Let me get my probe masters patched in here. Alright, so here is the 5 volts for DC. And we are getting 4.98 volts. Okay, let's go ahead and switch over to the AC voltage. And we are getting 5.53 volts. So basically what that means is it's adding 11% to the actual measurement, which means this is a averaging meter. That's a shame. Okay, let's go ahead and take a look at the hertz and the duty cycle. Getting 99.9 hertz, okay, and 49.9% duty cycle. So yeah, not bad there. All right. Let's go ahead and, since we got these patched in like so, let's go ahead and go over to the resistors. And we'll start with 100 and work our way up. Okay, here is the 99.99. And it is reading it as 100.1, 100.2, okay. Had a little trouble making up its mind there. That's fine. Okay, next up is the 1.0005 kilo ohm. And we are getting 1.000, okay, not too bad. All right. Next up we have the 10.0044 kilo ohm. And we are getting a little bit slow on resistance. 10.00. Okay, not bad. I'll take that. All right, next up is the 100.064 kilo ohm, and on this one we are getting 100.0 kilo ohms. Okay, well, all in all, not bad on the resistance. Let's go ahead and switch over to the caps. Yep. There we go. Okay, and we are picking up some residual, so let's go ahead and roll this out. Okay, we're going to start off with the 992 picofarad. Let's see what we get here. All right, hold on a second. Wow. All right, let's try that again. 992. Yeah, 1.4 nanofarads, that's way off. All right, next up is the 10.07 nanofarad. I tend to see that too on capacitance readings with averaging meters. Okay, this is supposed to be 10.07 and it is reading it as 10.32, so again that's a bit off. Alright, here is the 100.6 nanofarad. And that one's not too bad, 100.4. Okay, and last but not least, let's go up to the 1.007 microfarad. And again, 1.032. So didn't do too bad on that one. Okay. All right, last but not least, let's go ahead and do the current here. So we're going to need to switch over. Here's the other cool thing about this safety feature. If you try to switch over to something that, yeah, see, it won't let you move the selector. So that's actually a nice safety feature. I want to get out of there. I'm having to do this at a weird angle, so pardon my difficulties. All right, so let's go ahead and put it into. Well, let's just go ahead and run it in microamps since we're going to start with DC. Let me get it in there. Okay, so this should be 0.9996 milliamps, and we are getting 998 microamps. Not too bad. We can switch it over down to milliamps. It's actually reading it, interesting. Let's see, I would still say that this one is probably the more accurate of the two. Yeah, 998 microamps, that's actually quite good. So, it seems like this thing is pretty decent on current. Yep, pulled it off too fast there. Alright, let's switch over to AC. And again, the same thing that what I was expecting to happen here is that it's adding 11% to the actual reading. This should be basically 1.001 milliamps or 1001 microamps, and it is reading it as 1112 microamps. So yep, milliamps. Yep, same deal there basically. Okay, next up we have the Fnirsi SG-003 current test, DC current test. So let's go ahead and turn this on. One thing I forgot to mention in the overview, let me get this down a little bit. There we go. One thing I did forget to mention in the overview is this is a 4,000 count multimeter. So let's go ahead and turn this on. In fact, let's try this in microamp mode and see if it'll take it. And it does go over a little bit. Okay, so we're getting 4003 microamps. So that's actually pretty good. All right, let's see how far up it'll go before it flips over since we're here. Okay, looks like it's going to flip right at 4049. Okay, all right. All right, so let's continue on here. Let's go to 7 milliamps. And it is reading it as 7.03, slightly high. All right, let's go to 10. Again, looks like the error margin is increasing, 10.05. All right, let's go to 15 milliamps. continuing to increase. That is a nice feature. I do like that auto dimmer. 15.08, and then let's go to 20. And we are getting 20, basically 20.1 milliamps, so that's a little bit off, 20.11. Okay, here we go with the AD584M test. As normal, I have my reference meter patched in, along with the test subject today, the BTMETER 770G. We're going to start off at 2.5 volts, so here we go. Okay, on the 770G is reading it as 2.493 volts, and we're getting our customary 2.5006. A little bit cooler in here tonight, 2.5007, the customary on the reference meter. Let's go to 5 volts. Getting 4.99 on the 770G, and the usual 5.0055 on the UNI-T. Okay, here's 7.5. Getting our usual 7.502 on average on the UNI-T, and the 770G is showing it as 7.48 volts, a little bit low there. Okay, here's 10 volts. And we're getting our customary 10007 on the UNI-T, and the 770G is showing it as 9.98, wavering down to 9.97 there on occasion. Okay, let's go ahead and try the 32 volt test off the power supply. Let's see what we get here. Give me just a second to get these patched in. Okay, and on the UNI-T we're getting 32.011. It has been on for a little while, which is why it's reading a little bit higher than normal tonight. And on the, as you can see on the 770G, it's a little bit short, about 80. Yeah, it's actually about I would say, oh geez, about 80, 90 millivolts short. So unfortunate, but yeah, a little bit low on the high side. Okay, here we go with the continuity test and the rest of these tests. Just figured I'd go ahead and do this. Something else interesting I found on this thing, if you'll take a close look at the switch here, just take a quick look at the switch. As you can see, it lights up. You see that lighting up? Now we hold it up. Take a look at that. That's kind of neat. All right, so here we go with the continuity test for the stock leads. It's trying to zero out. It's kind of slow. Gets down to about, and the best you can do is about 1.8. They're okay. They need to be cleaned. They got oily crap all over them. All right. They're fine. What I like about these more than anything is they don't try to fold back as much as some of these other stock leads that I've dealt with do. Although they do like to tangle like the rest of them do. But yeah, as you can see, I very easily got those thrown back together. All right, let's move on here. Let's do the Probe Masters. Same test. Come on. Yeah, those. I really like the Probe Masters, but this silicon sometimes just likes to hug on everything. But anyway, all right, here we go with the Probe Masters. Same test. About the same kind of reaction. I am getting it down to about 1 ohm resistance. Okay, 0.7, 0.6. Getting a double beep there. That's okay. These definitely zero out a little bit better. Shut up. All right, so let's go ahead and get into the, let's try the LEDs here. Okay, here we go. Red. Oh, wow. You can't see it. It is just barely lighting it up. Okay, yellow, nothing. Green, nothing. Blue, nothing. Wow. That's not good. Okay, well, this thing is basically useless on LEDs in every way, shape, and form. Won't light up anything. That's very disappointing. Okay, we'll find out why here in a minute. Okay, let's go with the rectifier diode. .507, okay. Switching. .478, okay. It's okay, a little bit low. Schottky. .175, a little bit low, but not horrible. All right, fast recovery. .566, again, a bit low. And last but not least, the germanium, and we are getting .257. So it reads diodes, but it is reading them kind of low. Not the greatest on that. All right, let's go ahead and see what we're getting on the output voltage here. So take a look at my UNI-T, and let's see what we get. 1.5702 volts. Okay, well, that'll explain a great many things. All right, let's go on to the, let's go ahead and try some resistors. Make sure I won't block the view here. I may have to move this out of the way. Yeah, we're good there. Okay. Not showing anything. Well, let me get into resistors. Okay, we are getting some residual, so we should be able to rel this out, so let's go ahead and try to do that. And it does. All right, here's 1 ohm. Slow. But we are getting 1 ohm. All right, here's 10. Again, slow. But 10.0, so that's good. 100. Slow, but yeah, that's about right. Okay, 1K. All right, let's take it out of rel. Come on. Maybe it didn't take it out of rel. Okay, why is it not reading that? Well, that's strange. There we go. Maybe it was just because it was being slow. I was just being impatient. Okay, 0.998K. All right, that's good. Here's 10K. Yeah, that's what it was. 10.06. Yeah, that's all right. Here's 100K. 100.2. Not bad. 1 meg. Yeah, that was just me being impatient. 1.009. That's right on. Here's 2 meg. 1.996, I'd say we're pretty good there. Here's 4 meg. 3.976, we're good there. All right, let's go to 10 meg. Taking a while to get there, but 9.96, yep, good. Nigel Tufnell mode, 11, 11, 11, and we are getting, should be getting under, a little bit under 11. And we are at 10.95, I'd say that's pretty good. All right, it's fine on the resistors, kind of slow. Okay, we're going to do the capacitance here, so let me get this set up real quick. I will say we do have a limited range here. At least according to the manual, it says this tops out at basically 100 microfarads, so we're going to see how that goes. Let me get that over to, okay, let's rel that out. Okay, this is 100 picofarads, and we are getting what appears to be 230 picofarads, so that's not good. All right, 150, off. 220, off. 330, off. 470, yeah, way off. 560, still off. 680, yeah, way high. 820. Pretty, yeah, too high. Here's 1 nanofarad. Still too high. Okay, 1.5. Still too high. 2.2. Yeah, that's way too high. 3.3 nanofarads. Yeah, it's still high for this one. It should be reading as about 3.05. All right, here's 4.7. Where was I? Okay, here's 4.7. Still high. 5.6. Yeah, same deal. 6.8. Yes, it's getting better, but yeah, it's still slightly high. 8.2 nanofarads. Yeah, that's still high. 10 nanofarads. It's okay, getting there. See, 15. This should be low, and it's actually high. Actually, this should be high. Okay. Let's see, 22. Yeah, that's about right. Okay, so it looks like it's basically the usable floor on this is about 15 nanofarads. I'd say 10. Not that great. Okay, yeah. 33, high as expected. 47. Yeah, that's about right. 56, this should be low, and it is. Oh yeah. 68, again, should be low, and it is. And then this should be around 102 to 103 picofarad or nanofarads, and that's reading it as 103 nanofarads even. All right. So yeah, again, a little bit disappointing. All right, so we do have an upper limit in the manual stating that it is going to top out at. I'm not even going to bother with the 22 puff. I know it's not going to read that accurately. Let's see if it'll read the 85. Yeah, there we go. Just slow. It's reading, pretty close. But this will top out at 100, or supposed to top out at 100 microfarads. So here's 1 microfarad. Okay, that's good. Let's go to 10. Yeah, that's pretty good. All right, let's go to 47. This should be more like 44. And just broken a solder joint right there, jamming it in like that. 45.98. Yeah, that's okay. All right, let's try 100 and see if it'll read it. This is slightly over 100. It's about 101. It's trying. It's reading it as a low. Well, yeah, we're still in nanofarad range there. Boy, that's odd. Yeah, over limit. Let me take it out of rel to make sure. Let's try 100 again. Still slow and stupid. Come on. Oh boy. Yeah, over limit. So that's disappointing. So your usable range for capacitance on this meter is 10 nanofarads to just under 100 microfarads. Not very wide. Okay, here we go with the AC voltage test for the outlet. I'm going to go ahead and jam my probes in here and see what we get. Getting a 123.6 looks like, 123.5, and for the hertz, we're getting 60 hertz even, and the duty cycle is showing as 49.6. It should be reading it a little bit higher than that. So let's go ahead and try the NCV test. Now this is really interesting how you do this. You basically just hold this in, like so. Just hold this NCV button in. It works just like one of those pen ones do. Let's see if it does the LED light. Yep. I would say that works. All right. Okay, here we go with the test for the thermal probes. Let me get them patched in here real quick. And this, I believe, only reads Celsius. Yeah, not changing anything. Okay, so we're getting 27 degrees Celsius. Let's try the body heat. This should go up to 30 something, I would guess. And it is reacting. And yeah, I'd say that's about right, I guess. 33 Celsius. All right. Give it some fire. See what happens. Of course, the nice thing about this is it's easy to do this fire test. Yeah, I'd say we're getting a pretty good reaction there. Yep, got it up to almost 300 Celsius. So I'd say that works. Maybe slightly generous in its readings, but for the most part, it's fine. Okay, here we go with the frequency test. Now, according to the manual, the BTMETER 770G has a frequency range of 5.12 Hertz all the way up to 5.12 megahertz. So we're going to run our usual, regular, everyday frequency test with a sine wave with an amplitude of 2.5 volts, and we're going to start at 1 Hertz, and let's see what happens. So here we go. Okay. All right, that's 1 Hertz, and it is reading it as 0.999 Hertz. Our duty cycle is pretty sad looking, but it is reading it. Okay. Let's go up to 10 Hertz, and we are getting 0.999 or 9.99 Hertz. Duty cycle is about the same. All right, we'll look at that here in a little while. Okay, here is 100 Hertz, and is reading it as 99.9 Hertz. Okay, looks good there. All right, let's go ahead and go to 1K. That was me, went too far. And we are getting 0.999 kilohertz. All right, let's see, duty cycle, any better? Yeah, not really. Okay, let's keep going. Let's go to, there's 10 kilohertz. Reading it as 9.99 kilohertz. All right, let's keep going. Let's go up to 100. You got 100K, and it is reading it as 99.9K. Duty cycle, still crapping. All right, I'm gonna quit looking at that. That just seems to be arbitrary. All right, here we go with 1 meg, and we are getting 0.999 megahertz. Okay, all right, let's jump up to 5. See if it'll read that. And we're getting 4.998. Okay, well, let's go ahead and let's give it a shot. Let's see if it'll read 10. And it is reading 10. 9.99 megahertz. Wow. Okay, well, let's keep going. Let's go to 20. Will it read 20? No. Okay. Let's see. We get it at 16. 17, 18, 19, nope, we're losing, yeah, it's not reading it there, yeah. So we lose it at about 18 megahertz. This thing is only rated for 5.12. I'm not going to torture it any further. I think it did just fine on this test, better than expected. Okay, and here we go with the pros and the cons of the BTMETER 770G. First, the pros. These slot protectors are actually a very nice touch. Not only do they block out the holes that you shouldn't be putting your jacks in, but when you do have, like, say, for example, if you're in AC voltage like it is right now and you try to switch over to amps or whatever, it's not going to let you do it. It will not physically let you turn the selector over that way. So that was a very nice touch. Best safety features I've seen since I reviewed the Kuwait's HT118A. Alright, it is easy to use. I have no problems there. I didn't have to look at the manual at all, pretty much, except just for a couple of specs. The manual is just a single sheet fold out, but it's legible. It's in a font that you can actually read, and I have no problems with that. Another cool thing, and I'll show you again real quick. Let's turn off the overhead. This auto dimmer is really a nice touch. You never have to bother turning it on or off. It'll take care of that for you based on the light. And there's also a little light down in the dial, which I thought was kind of neat. Anyway, so cool little, just a cool little thing. I like that. All right. Also, it's very affordable. Like I said, I got this for $9.99 from Amazon. The link is in the description. Whether it's still available or not is, I don't know. The last time I looked, they were out of stock. So if you want this, you may have to wait on it. Another thing was I like the fact of how much it worked out of spec on frequency. It's rated for a maximum of 5.12 megahertz, and we got this to read all the way up to 18 megahertz for basically a $10 meter. That's not bad at all. Okay, let's get on to the cons, and unfortunately there are a few. First and foremost, while the leads themselves are not that bad, the included leads for this meter, the continuity reactivity is mediocre at best. It's a little bit slow and sluggish. I didn't really like it a whole lot. It's usable, but it's not the greatest. This is not true RMS, so you will not be getting accurate AC voltage readings, period. You're going to have to subtract 11% from whatever readings you get. The voltage and the current readings in general are not accurate, especially in the AC mode, like I previously mentioned. But even in DC modes, it's, again, mediocre. I wasn't all that impressed with it. In general, this meter works very slow overall. It's kind of slow to range and other things. Very limited capacitance range. I mean, you're stuck with 10 nanofarads to 100 microfarads, and that's it. That is all you get with this one. So if you need to measure either below that range or above that range, you're going to be out of luck. Diode readings tend to be a little bit low. I hate to nitpick at this thing, but the simple fact is that the diode readings on this are below average. The output voltage is also extremely anemic at a whopping 1.57 volts. Was not impressed with that. You can't light up anything with that if you need to test LEDs. I know that's not important to a lot of people, but some people it is. So that's why I mention it. Last but not least, the magnet on the back is basically useless. I mean, I have to ask, why is it even there? It's not strong enough to hold the meter up on a metal surface anyway, because I tried it on a couple of surfaces and it just fell right down to the floor. So it's useless. Why is it there? Okay, and that brings me to the conclusion of the BTMETER 770G. In all honesty, this meter, while sporting some interesting and unique features, in my opinion, is not up to snuff with the other meters that I have reviewed in the super tight budget digital multimeter series. It just isn't. It's also one of the least accurate and most limited meters I have tested on this channel. The bottom line is, I would recommend getting either the previously reviewed PeakMeter PM8233D Plus or the Zoe CT C4 instead, as both are better digital multimeters overall. I hate to do it, because it's kind of a sad moment on this channel, because as the emperors did in ancient Roman times, yeah, I can't recommend this. I'm sorry. You can do better for your money. Anyway, that's going to do it for this review. Thanks for watching. This is Suez 778, and we'll see you on the next time.